Hi, this is Supplementary Algebra 1 lesson, Lesson 88, Division of Polynomials. So along with this lesson and our graphing through our slope-intercept method and our new word problems involving coins, that's probably about as far as we're going to get in Algebra 1 this year. I think we might get as far as Lesson 95 in your book. That's about it. This is one of the topics we're going to have to park on for a while. It takes a bit of practice. There's a specific procedure involved. It just takes practice because a lot of times it isn't readily apparent. So what are we doing? We are dividing by polynomials. In other words, expressions with more than one term in it. Okay, so before we do that, let's just back up. I have a long division problem here, and so one thing to keep in mind, we are not doing anything very radically different than what we've been doing in grade school in long division. Okay, the long division problem here with a solution. I'm going to be referencing that a couple times through this lesson. And another thing to keep in mind, okay, when we have been multiplying polynomials, here we have a trinomial, 3 terms, okay, we've been multiplying it, say, by x here. We multiply by the distributive method, multiply each of these 3 terms by x. When I multiply it out, I get this trinomial right here, okay? So, another thing to keep in mind, when we are dividing, we are simply undoing a multiplication. Okay, so if I want to undo this operation I just did in multiplying this trinomial by x, okay, I can take that result, that trinomial, and I divide by x now to undo it. Okay, now when there's just a monomial, okay, and we're not dividing by polynomials right now, we'll get there. Okay, this can also be expressed as 3x to the 4th plus 7x to the 3rd minus x squared divided by, here it's divided by x, everything divided by x. Okay, I have a common denominator of x. I can distribute that common denominator out. 3x to the 4th divided by x plus 7x to the 3rd divided by x minus x squared divided by x. Okay, then I can use cancellation or my power rules of powers. Okay, 1x cancels with an x here to get 3x to the 3rd. Gives me a 3. And x cancels with this x to the 3rd to give me an x to the 2nd. So I get a plus 7x to the 2nd. And again, an x cancels with 1 here to give me a minus x. Okay, so I notice when I do that, I get the original expression up here. I have undone this multiplication of x by dividing the x. I've taken that multiplication right here and divided by x. I get my original term. Okay, my original terms. Now, I can do it that way with monomials, and that might be easily identifiable to you. We've been doing that as well. Okay. Another thing I can do is, instead of doing it that way, I can take this division by x and I can express it like a long division problem. I can take a long division and put that x out here. Okay, and then the same way, what do? Okay, I go over here. Okay, I can't, 12 times what will give me 4? I can't do it, so I skip to the next one. 12 times 4 will give me 48. Here, x times what goes up here will give me 3x to the 4th. Well, I need a 3, and I need 3 more x's. 3x to the 3rd. Okay? Then in the same way, okay, how do I get that 48? Well, I take the 4 times the 12, okay, that gives me the 48 right here. I take that x times the 3x to the 3rd, okay, I put it over here. I get 3x to the 4th. Excuse my penmanship, or chalkmanship, I guess. I put a line under it, okay. Now, in this division of polynomials, I'm just going to erase this right now to show you what we're going to now. In long division, I subtract 49 minus 48 gives me a 1. Okay, and I can do the same thing here. I can subtract, but I'm going to use this simple method to show us now when we're doing division of polynomials, what we're going to do, instead of subtracting, we're going to change the sign of this one and then add them. Okay, I'll show you how that's important when we actually divide by polynomials. But really, that'd be the same thing that we would do here. Okay, if I were to change the 48 to a minus and then add them, it would still come up to be 1. Okay, so whether I take a number, a positive number, and subtract a positive number, or I take a positive number and add a negative number, it's the same operation. Okay, we're doing the same thing. It'll be easier to do it this way going on. So I add these together, well, they get 0. Okay, then what do I do in long division? I drop down the next number. I do the same thing here. I drop down the next term. Okay, and I bring the sign with it. 7x to the third. So now I ask myself, x times what will give me 7x to the third? Well, I need a positive 7, and I need an x to the second. X times 7x to the second is 7x to the third. Okay? I do the same drill. I change the sign and I add them. It's 0. Just like here, I drop down the next number, 7. Okay? I drop down the next term and I bring the sign along with it, a minus x squared. Okay? X times what will give me a minus x squared? A minus x. And x times a minus x will give me a minus x squared. Okay, what do I do then? I change that sign and I add 0. I have a 0 remainder. Okay, that is the basic drill for doing division with polynomials. I did it with a monomial to show you the process. It's no different than what we did with long division. Okay, now let's go ahead and go to a binomial. That's a type of polynomial with 2 terms. We're going to do the division. Okay, so what am I going to do? I'm going to want to divide 3x to the fourth plus 10x to the third plus 6x squared minus x. And I want to divide it by, I don't want a square root, I want to divide it by x plus 1. Okay, and in the book they have this convention, you can do that to show that it's a division by a polynomial. So why a polynomial? I have 2 terms now that I'm dividing by. Okay, now this is problematic because let me just show you here quick. Now, if I had that same problem that I just did, okay, and I multiplied, instead of multiplying by x, I'm going to multiply by x plus 1 now. Okay, I notice here I have to do the distributive property 6 times. Okay, I'll have 6 terms. I'll have to combine them, okay, into terms. The answer being, when I combine them, looks something like this. Okay, but now if I want to undo that, okay, and divide the whole expression by x plus 1, okay, my common denominator is x plus 1. So if I divide every term by x plus 1, and let's just look at this last term, okay, if I'm going to divide that last term, x divided by x plus 1, is very problematic for me, okay, because I have two terms in the denominator, okay. This I cannot split. This does not equal x over x plus x over 1. That's a big no-no, okay. So we can't split that apart like we did in the previous problem with just a monomial dividing by, okay? It brings us many problems, and for that we have to have a special procedure, and that's what this lesson is about, okay? So here's the special procedure. We write it out in long division form like this, and we must write both terms in descending order. In other words, the power of the variable from the highest power, power to the 4, power to the 3, power to the second, power to the first, in descending order. Okay, if they don't give us the problem in that order, then we have to rearrange it in that order. Again, the what we're dividing by must also be in descending order too. X to the first power, x to the 0 power. Okay, so once we have that, we put it in long division form. Okay, then it's the same drill. Okay, we look at the first terms only. Okay, look at the first terms only. What must x be multiplied by to get 3x to the 4th? Okay, well, I need a 3. Okay, and I'm missing an x to the 3rd, an x to the 3, because an x times x to the 3 will give me x to the 4th. Okay, then I will have 3x to the 4th. Okay, then I go ahead and I multiply that out. Okay, so if I have a 3x to the 3rd and I multiply it by an x plus 1 right here, let's go ahead and multiply it out. I get a 3x to the 4th to the positive, 3x to the 4th. Now, because we are dividing by a polynomial with two terms, I also multiply 3x to the 3rd times 1, and I list it under the next term. Okay, it is a positive 3x to the 3rd. Then I draw my line to subtract, okay, like I would do over here to subtract. But again, with polynomials, what we're going to do, we're going to change the sign and add. So that means I'm going to change the sign of both terms here. This will become a negative as well as this will become a negative, okay? Because what am I doing? I'm subtracting the whole expression, okay? If I subtract the whole expression that I had, 3x to the 4th plus 3x to the 3rd, I'm subtracting that whole expression. I must multiply that negative sign out. It changes the sign of both of those. That's what I've done here. I've changed the sign of both of them, okay? And then I add 3x to the 4th minus 3x to the 4th. They cancel out, okay? It would be a 0. I don't really have to put the 0. I'll put it there for right now. A 10x to the 3rd minus a 3x to the 3rd leaves a positive 7x to the 3rd. Okay? So I've done my subtraction or adding the negative. Just like in long division, then what do? I drop down the next term. A positive, I drag that sign along with it. 6x squared. Now again, I do the same thing here, just like here. When I come up with a new number, I see what must I multiply 12 by, okay, to get into that new number. 110, I had to multiply it by 9, okay. Over here, I only look at the first term. What must I multiply x by to get 7x to the 3rd? Okay, well, I need a 7x to the 2nd, because x times 7x to the 2nd will equal 7x to the 3rd. Okay, I multiply those out. 7x squared times x plus 1. Okay, just like up here. 4 times 12 is 48. Okay, 9 times 12, I should say, equals 108. Okay, it's the same thing here. Let's go ahead and multiply this out. 7x squared times x is 7x to the third. Okay, always line up your terms that have the same powers. X to the third goes under x to the third. Okay, then 7x squared times 1 will be plus 7x squared. Okay, so what do I do here then? I draw my line to subtract, but I'm not going to subtract. I'm going to change the sign of both of these and add them together. 7x to the third plus a minus 7x to the third, well, they cancel out. Okay, then a 6x squared and a plus a minus 7x squared will equal a minus 1x squared. Okay, then I drop down my next term, minus x. Okay, I typically don't express as a minus 1, it would just be a minus x squared. Okay, then I repeat the same process over again, only looking at the first term and the first term over here. What must I multiply x by to get minus x squared? Well, the first thing I need is the minus sign, so I need a minus, and then what do I need? Well, I need another x, because x times x will equal x squared. Okay, so then let's go ahead and multiply out. I got a minus x times an x plus 1. Let's do the distributive. I get a minus x squared. I get a minus x. Okay, then I draw my line to go ahead and subtract that, but I'm not going to subtract. I'm going to change the sign of both of these and add them. Okay, so I got a minus x squared and a positive x squared. They cancel. I get a minus x and a positive x. They cancel. I get 0 as a remainder. Okay, so for this problem, the answer when I divide this 4-term polynomial by x plus 1, I get this trinomial right here. 3x to the third plus 7x squared minus x. Okay, now let's go ahead and do that example 88.3 I mentioned in your textbook. Now, not all of these will come out without a remainder. And that is a very distinct possibility, just like in long division, okay? Sometimes we have a remainder. The division doesn't come out exact, and that's going to be the case in this last example, okay? So we have a 3x to the third minus 2x squared plus 5x plus 50. Okay, I want to divide that by x minus 3. And again, they have a convention to do that when dividing by polynomials. Okay, so let's go ahead and do this example. Same thing. We only look at the first term. What must I multiply x by to get 3x to the third? Well, I need that 3 for one thing. Then x times what will be x to the third? X times x squared. Okay, then let's go ahead and multiply those out. I said 3x to the squared times x minus 3. Let's go ahead and do the distributive. That gives me 3x to the third. That gives me minus 9x squared. I draw my line to subtract, but I don't subtract. I change the signs and I add. 3x to the third minus plus a minus 3x to the third, they cancel out. Okay? Then I have a minus 2x squared added to a positive 9x squared gives me a positive 7x squared. Okay? I drop down my next term, plus 5x. Okay, then again, I repeat the process. What must I, we'll only look at the first terms. What must I multiply x by to get 7x squared? Okay, well, I need a positive 7 and an x. 7 will give me 7 times 1 will give me 7. X times x will give me x squared. Let's go ahead and multiply those out. Distributive property. Okay, 7x times x will be 7x squared. 7x times a minus 3 will be a minus 21x. Okay, I can draw my line to subtract. Again, I'm not going to subtract. I'm going to change the signs and add them. So I have a positive 7, a minus 7. These cancel out. I have a positive 5x, a positive 21x. That gives me a positive 26x. Okay? I drop down my next term, plus 50. I repeat the process all over again, looking at only the first term. X times what will give me 26x? I need a positive 26. Okay? Let's go ahead and multiply it out. 26 times an x minus 3. I do the distributive. I get 26x. I get a minus 78 when I multiply that out. Then I can subtract. But I'm not going to do that. I'm going to change the signs and add them. Okay? A 26x, a minus 26x, they cancel out. A 50 plus a 78 will give me 128. Okay? Now I notice here, I'm at the end of my expression. I don't have any more terms to drop down. Just like I do in long division, when I have a remainder, I have no more numbers to drop down. Okay? I have two ways of expressing that. I can express that as a remainder 3. Okay? 12 divided into 49,107 will be 4,092 with a remainder of 3. Or I've learned I can express that as a fraction, 4,092 and 3/12. Or I could reduce that to 4,092 and 1/4. I reduce that fraction. Okay, what I'm going to do in polynomial division, I'm going to use this this second thing. I'm going to express the remainder as a fraction. And what is the fraction? Whatever is the remainder part goes in the numerator, up here in the numerator. And what is it? It's a positive 128. Goes in the numerator, just like my remainder goes in the numerator. What goes in the denominator? Well, what I'm dividing by. The 12 goes in the denominator. What am I dividing by here? X minus 3. The x minus 3 goes in the denominator. This is how we express the remainder in a division by a polynomial problem. It looks rather weird, okay, but it's the same thing that same convention that we use for long division. Okay, so for this problem, this is our answer right up here. Okay, 3x squared plus 7x plus 26 plus 128 divided by x minus 3. Yeah, it looks a little strange, but that's what we get more often than not when we divide these polynomials. We won't get an exact division like we did in the first two problem, or that first division problem. Okay, we'll more likely get a remainder expressed in a kind of a weird format there. So those are the basic steps for doing polynomial division. Now, sorry for the length of this video. There's really no easy way to go about it. I actually had 2 more examples here of tricks of the trade, but we'll be doing more of this all this week and next week, so get it down. It's nothing more than long division. Real quick, express the polynomials in descending powers, okay? And then go ahead. Your first number you put up here, you're only looking at your first terms, okay, to get your first term up there, okay? Then that first term, you're going to multiply it by what you're dividing by, okay? 3x squared times x minus 3, x minus 3. That's what we've done. Each term is multiplied what we're dividing by, okay? When we multiply those out, we line up the terms that are similar, okay? The x to the thirds go underneath the x to the thirds. The x squareds go under the x squareds, okay? The numbers go under the numbers, okay? And trick of the trade, we don't subtract these polynomials. We go ahead and we change the sign of the terms there and we add them, okay? That helps us stay out of trouble. It's the same operation, it's just a different way of doing it, okay? And remember to drop down, once you're done with that subtraction, which is the addition of a negative, make sure to drop down your next term. Start the process all over again. Drop down your next term. Start the process all over again. And then finally, express any remainder as that remainder number in the numerator divided by what you were dividing by originally in the expression. In this case, x minus 3 goes in the denominator. So again, sorry for the length. It's just a process, a procedure you have to memorize, and I hope the comparison to long division helps you understand what's going on. So shoot an email or a text message if you have any questions with this, but we'll be doing lots of these here in the next couple weeks through the end of the year. Okay, so long for now.